Hello everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video for your enjoyment. So what we're going to be doing in this video is I'm going to be starting a new series here. It's called Reverse Engineering. So we're going to basically do this in BASIC. We're going to take a BASIC program. I found one example I'm going to work on. Basically I have a couple examples I can work with. But like I said, this may be a short-lived series, I don't know. But anyways, we'll be reverse engineering a few different games. So we'll be taking one game that's already been created. There's one here for Ahoy from the Ahoy magazine I found online, and we're going to be reverse engineering it to see what we can do to try to make it better. So let's take a look at that. So this is the game we're going to be reverse engineering. It's called Catacombs, and like I said, I found this online through a magazine called Ahoy magazine. So let's take a look at this. First, I'm going to show you a little bit about how the game works and everything. Basically, it's just kind of like a puzzle game. Notice our sprite, our character, moves here and makes a lot of crazy sounding moves. Why did I choose to engineer this game? You'll see so in a minute why. Now, there's our enemies chasing us. You can see that little, looks like, I don't know. So see? The reason why I want to engineer this game is because this is a fine scroller. The first one I found in BASIC in a long time. Ooh, I think I trapped myself. It's probably going to get me. So what we're going to try to do is we're going to try to change the background. And we'll basically try to make this like multicolor. And we'll just kind of play it by ear, see what we can do. We'll change something with the title screen, some things that I've come up with. And just try to improve it a little bit better. Not that it might need a whole lot of improvement. I think it's kind of cool. You're supposed to basically be able to get, like, this is a treasure or gold right there. And you got to find the keys in this little maze. That's the first fine scroller I've actually found in BASIC. I was actually pretty excited that I found this one. Because later, we can implement this into the machine language project, too. So anyways, I'm going to stop it for now. Oh, I just realized yeah, there it goes. Okay, so we're out of the program now. Now, if we list it, you'll notice that it's still got a sprite on the screen, so we're going to turn off the sprite with this poke. We're also going to restore the character set with this memory location, put it back to 21 instead of leaving it at 31. And it's got a few other things going on here. So now we're going to go in and we're going to take a look at the code here a little bit. So as we appear at the top here, we can kind of see this is initialization of the character set right here. And then we've got basically the, I guess there's a snake or something in here too. There's a couple different characters in the game. Since I don't have a whole lot of time, I'm not going to sit there and try to change every single character, but we're going to probably change the look of things. And like I said, we'll try to change maybe, I don't know, some other things in it. We'll just see what we can do here. So here's where the monster movement begins right here in lines 380. It uses function calls. Function calls are really good because they actually allow you to speed up routines, or basically, I like to say variables in the program. They're not too complicated. I haven't really gone over those yet, but basically, we could probably go over that in another video. Right here, we got B plus 24, and I didn't need to grab my Excel sheet here real quick. Oh, and before I forget, for those who want to know, I updated the Excel document here too. I changed this so the hexes are over here. So if you want to go ahead and go to the GitHub, I'll put a link there and you can download that. And it'll be there available to you. You'll see, and just look for the dates on it. So anyways, getting back to this, what I was doing is I was going to go in here so I can look up this B plus 21. B starts at register 53248, and that's where all the sprites get initialized at. So in this cell document, I've actually made it easier for me to find each one. So if it says B plus 17, I know what address that is and so on, because I've got it all written down here now. I spent about an hour doing this. Let me just pause here while I find it. Okay, so the B plus 21, this is what enables the sprite, so we're going to leave this. I think they might have turned it off here. Whenever you get killed, they turn off the sprites. And the B plus 33, this is the background colors. They basically turn that off too. That's basically when the game is over. That's the game over screen there. Okay, so we're going to go back down through this. The B plus 17, that's actually the vertical fine scrolling register. So that's actually where the fine scrolling goes into effect right there. So obviously we'll need to leave that there. Here's where the gold, we could go in, we could change the gold if you wanted, you know, to increase the gold points. You just go in here and you change this line. So the easiest way is just to list it. Since we can't insert, we'll just have to type it in again. Is that reverse on? Yeah, that's reverse on. Okay, so I think it's this one. And then we're going to change this number to whatever we're going to change it to. We're going to make it 200. Say 200, you need to say G equals G plus 200. There's my plus. And then we just leave the other lines in unless we decide to change those. And that's going to change the gold when we go over a gold. And let's take a look here. Make sure I'm not missing anything. So let's see what this V plus 27 or V plus 39. What's all this? I think these might be the colors. Just gonna look at my guide here real quick. Okay, so it says Sprite 0 color register. So that's basically there's sprites in this? I didn't know there were sprites in this. Let's go in and play with that one. This one is changed to white. So if I change this to like 2, it should be red. And these are just simple changes. I mean, nothing really complicated here. But what we're trying to do, our goal is to try to make it better, make it look prettier as we go through it. So V plus 29 is the sprite register. Oh, I think I just changed the wrong one. 27 is the, let me see here. It's the display priority register, so I need to probably put that back to what it was. I think it was 1, was it? And then this one we can change. So this is the yellow. If you wanted to change it to red or whatever you wanted to change it to. Blue, it's 6 is blue. Now we go to run it again here in a minute. You'll see the changes. Let's see what 34 is here. I'm just checking out this one right now, V plus 34. And take a look over here. So that's background color 1. We could go in and change that one. So they got this one to white. We set that to red, and then we should see the changes once you run this. And here's the background color. I think that might be for the map, 36. Let me see. That's an 11. I don't know what color that is. Maybe we could do 13 like a green or something. So you should see it change. And we'll speed up the player next, and I'll show you a few different things. Oh, I actually just changed these colors. That's what it was. You saw those. Those are the multicolors that change. Oh, before I forget, also, I'm going to make a note real quick. I'm going to show you how to throw in a routine here to make it so it doesn't have to reread the data all the time. You do it with a peak. Okay, so I changed something already. You see, I changed the background here. Instead of this was the light, basically. I changed it to a blue, but we can put it back to yellow. That's supposed to be the surrounding light. We could also go in and we could set initialized characters around it. Oh, I see, it's got him cornered on the sprite. That's actually kind of cool. That means actually we could actually add in a sprite to this. Now that I think about it, it's detecting his position here with this character, so we could probably add a sprite for the movement of the guy. And that would probably be kind of cool to do, I think. Okay, so I guess what we could do next is, like I said, we'll probably go in and we'll speed up the guy here a little bit, and we'll start changing some of these graphics. So give me a second to pause. Okay, so I'm back, and what I've done here is I've gone ahead and I've labeled some of the registers here for the sprite. This is for the sprite registers. This is where everything begins on your Commodore 64. So 53241, wherever you see the B equals 53241, that's basically saying 53241 plus whatever to reach this number. So if you take 53241, for example, this should show 53248, excuse me, and you say B plus 27, you'll see it shows 53275, which is the sprite enable register. So that's essentially all we're doing is we're just calculating where those positions are instead of just trying to set every poke to 53248, 53275, or whatever. It's just a faster way of initializing them and saves a little bit in code. So anyways, just a little bit lesson there. So we're going to go ahead and change some of these registers now. So let me just relist this here. And I'm going to turn that sprite off here so we don't interfere with anything. 53249 or 69, 0 turns off the sprite. And if I looked at my little map here, let's see, 53269 is v plus 21. So if we just say v plus 21, it'll do the same thing right here. This will turn off the sprite too, like that. Okay. And so now that we have these registers defined, we can go ahead and you can easily change these. So earlier we saw the blue background. So that's this one right here. So if we change this one back to 7, that'll turn the light back on the way it was. The 23, as we can see in our example here, is the Sprite vertical expansion register. I'm going to change that out of curiosity just to see what it does. Let's see. Because if you set the bits here, it's set to bit 1 right now, which means it's only going to set to 1 sprite. We really don't need to really do anything, but we could add an extra one in here. We got the vertical expansion. We could also add the horizontal expansion. So let me just take a look here real quick. I'm making sure I'm looking at the right one. So it's 53270. So 53270 is v plus 22. So we could throw in a v plus 22, maybe make like a 195 or something. That'd be good right there. 195 poke v plus 22, comma 1. Oops. Comma 1. And we could play with that. And then we could go back up here. We'll leave that one expanded. And in v plus 29, we can see that's the sprite horizontal position. I'm sorry, sprite horizontal register. I don't know why I wrote sprite horizontal register. Let me see what that says here. Oh, expansion register. So it's sprite horizontal expansion register. That's the one we just changed, right? Expansion register. So that's the one we wanted to change. I don't know what this 22 was I just changed here. I thought I changed the right one. Let me just go back and double check. And I'm just looking at that Excel document. That's horizontal fine scrolling register. So we probably don't want to mess with that one. We could probably do some funny things with it, but I don't know what will happen if we change that. We'll just leave it there for now. We'll change it later, just for fun to see what it does here. So we're going to go ahead and leave that one in because we're going to leave it expanded. And this is just basically turning on the sprite so you can see it and its character data. We could set an animation by changing these values and creating sprite data to animate the player. V plus 21, we can see that that's just for the sprite enable register, so we need that to keep them on the screen. 34 is the background color register, so we changed something red earlier. We could put that to like, let's see, 4 is like a purple, I believe. The 3 is like a cyan. We could change it to a cyan. And 36 is a background color register. We changed that to 13. So let's make that black and see what happens on that one. So it'll probably change those main color screens as we run it again. Oh, and let me also, on the next example, to put that code in so we don't have to wait for the data to load all the time. So we changed this one. I think we might have changed, yeah, because this was a different color. So we got this back to yellow again. I think this map is actually coming from the assembly code because I know there's a routine in here, which we'll come across later. Oh, this cyan color was actually the, we'll just say that's the entrance. So we changed the entrance there. I don't really know what else we could really do. Let me see if anything else changed. I was just trying to see if anything else down here changed, like the keys or anything. Because you have to get keys to open up this door. There's several doors on the screen. Oh, I'm sorry, there's only one door. Oh, right there. I actually just saw it. Right there it is. That's the door. That's the exit right there. But you have to find a key to get out of here. Which is, of course, hidden in this crazy maze. Right there it is. Oh, if I go down here, that guy's going to get me. See, there's a little enemy hiding right down here at the bottom. See how it looks like that one? So we're going to go over here to kind of trick him. You see how it says key? We also changed the gold, so let's see if we can go find the gold if I don't end up dying here. I might have to exit out of this maze real quick because I end up dying otherwise. So we made it out of that level. you can see that the room changed for the next level here. So what I'm going to do is I'm going to go try to find where the gold is. The enemy changed too, look. Looks different now. I didn't notice that last time. It's that little dot on the screen there. Let's see what happens if I go down here. I know there's a gold around here somewhere. Oh, the black was this bottom part. That's what that was. Okay, there's a key. You could also change the messages for the keys. It just depends on what you want to do with it. Uh-oh. So he's going to get me if I don't go. It gives you kind of a little... There it is. It was right here somewhere. So now it'll say 200 for the gold. Oh, actually, it turned it black. Isn't that interesting? So that must have controlled... Isn't that like neat? Kind of we're like in the dark now. I actually like that. Like, that's actually a good idea. You know, we could make it so that you could maybe start it off in the dark or something, and then... Oops, he got me. And then from there, we could turn on the lights later once you find a flashlight. Stuff like that could be added into it, too. So I'm going to go ahead and... Oh, I also noticed when the main screen loads, it doesn't let you stop the program. Earlier, I thought it had it disabled the break key, but it basically, I think what it does is it's a routine. It's initializing, I think, an interrupt or something, which turns off the keyboard. So let's take a look here. I'm going to pause for a second. It's taking too long. Okay, I'm back. Fortunately, the program crashed earlier, so I had to reload it. So you may see everything back the way it was. What I'm going to do now is I'm going to try to change this little box around it, see if we can make it look like this little shape right here. So it kind of looks like a circle instead of a square. And let me pause to save some time here. So here's where the door starts for the sprite data. So we'll just need to copy that into over here, like in a new data statement. And then we'll just say light. I'm just going to copy. I think we're going to need all of these lines right here. Yeah, we should need all these lines right here. So I'm going to pause while I put that in. Okay, so something else I've been doing here is I've been working on the sprite routine here, and I've also been reverse engineering the entire code, or most of it. Some of it is going to take a little bit more time, and I wouldn't be able to do that in just one night. But I've got a lot of it done here. What I did, if you want to reverse engineer stuff, what you want to do is you want to go through the lines and try to figure out what is doing what. So I just basically went through each line like this, for example, from the top. This kind of self-explanatory, says printing message. We probably don't need to do a whole lot with that. This is just setting up the screen. This is setting up the character set. That you'll know just from looking at your Commodore 64 mapping guide. Or, of course, you can also go on GitHub and get the... Okay, got everything back. And so basically, like I said, we're just going to go through the code itself. And we'll start picking out things here. So I started this at 220. Actually, at the top here, excuse me, these were the ones we were defining earlier. So what you do is you want to kind of get the variables and figure out what all the variables are doing. So I just go and I find out where they're being initialized. Usually the smaller variables under 100 you don't have to worry about. They're not going to usually do a whole lot. You can't really do much in those areas, but anything above, usually outside of the page 0 range, which is about 255, you're going to want to pay attention to. Especially like 49.152, this is where the machine language starts, so you want to make note of what variable they use for that, and they use B. This one is 53.151, probably something to do with the sprites or something. Okay, it's off a little bit. Actually, that would have something to do with the machine language. It's probably something to do with the positioning of the maze or something. I don't know that. That's going to take a little bit more time to take apart the assembly code, which you can just basically get here, go to monitor, and we already know it's already stored it in C000, which is 49.152. The maze loads in 33C, which is 828. So if you went here, for example, let me pause to get there. Okay, just pausing to save time there on the video. So right here where it says 33, I don't know if you can see this, but it says 33C JSR B79B, this hex code. Right here, this is the routine. I found out this is the one that actually loads the map. So if you go here and you type in sys, I'll show you. Oh, I got to get rid of this first to do that. So if you type me back here, but I got up still. Time to pause again. I don't know. Just lost the keyboard here. Had an extra box up in here. So anyways, you go here, it's type, so let's say 28, comma, whatever. It'll draw the map. So that's basically, that's what's doing, is that's drawing the map. Now you haven't seen it redefined yet. That's what the redefine does later. I just wanted to show you that's what that's doing right there. And these are just regular variables for something else. This MX, MY, this is the monster X, monster Y position. I just know that from experience. Not sure what this is. This is the joystick, JY. This is the sound, initialization of the sound. There's a lot of functions in here, so I'll have to figure out later what's all that doing. Might have something to do with the way it's drawn the maze or something, I imagine. And this we looked at earlier, so now we're on to 230. This is the sound setup right here. So this is where all the sound, you can go in, you can change the sound values. 250 is the joystick routine. They make this one pretty simple because they write it out. Some of this other stuff I had to kind of look through. 280, this is where we just saw the maze load on the screen there, on the fast machine language load. And then we've got 360, the wall barriers. So here's the wall barriers right here, x equals tx, x equals ty. I just know from experience whenever you're seeing x or saving an x and y, that's just preventing the player from passing through the walls. Okay, here's the monster movement. That's in 380, which we have right there. 390 is the rest of the movement. 440 is the death or the end of the game. 510 is the gold value. 520 score value, just to save some time here. 540 is level increase. We can go there real quick. Oops. So right here, we see L equals L plus 1. That's where the player is increasing on a level. And if he reaches level 10, it restarts the game. It says right there, prepare for the next level. Otherwise, it'll just go to prepare the next level. Otherwise, it'll restart the game if it doesn't reach. If it's not yet at 10, it's just going to keep going to the next level every time. So once you hit 10 levels, the game is over. This is going to descend down. So this is whenever, well, the levels, every time you go to a new level, it's going to say descending down like you're going inside. I guess you're going under the earth or whatever. Descending down to the level until you win the game. This is some kind of a sound routine it makes whenever it goes down into the level. Here's some more function stuff, probably to do with the maze. Here's interrupt. Right here, 781, 782. This is an interrupt being used for something, which I'll take a look at that later. 630 is the dungeon generator. The complicated dungeon generator, I like to say. And then right here, let's see where we're at here. 630 randomized maze or dungeon generator. Oh, and the screen background is on 632. I wrote that down here. So it changes the screen background. Well, B plus 33 changes the background. So where's it at right here? B plus 33 is changing this based on the level. So you see this L less than 5. If it's not less than 5, then it's going to keep changing the level. Something's going to happen on 5, I guess. It's going to stay the same or something. And then 670 randomizes the maze, which right here, you can see this is kind of, I looked this up. This is the 49-152. So this is the maze being drawn. This is the bottom part of the maze right there. But it's randomized in the maze, drawing the maze on the screen here. And let me see. Color of the dungeon, 670. We went over that. So we can skip down here a little bit more. I don't know yet what all this randomness is, probably repositioning the maze or something. And then I skipped all the way down to, trying to stay consistent here, 830. So let's put 830. 830 is where the redefined character sets. This is those characters that you see in the game, like the monsters, the player, and all that. And I set it up here earlier to note which, since they actually identified that at the beginning, make it easier for us. The number is the skull. The $sign was converted into the wizard. The percentage sign is a bat, which we haven't seen yet. The spirit is the end, and the snake is the little quote there. Okay, so now after redefine the characters, the starting address of redefined characters begins at 14336. So this one didn't have a variable, so you want to make note of where the character set is initializing, and that's where it's putting in memory to change the character set. Okay, and then 880 is the machine language scroll. This is a very well documented program, so it's really easy to kind of take this one apart. Here's some of the dimension setups, reading in some basically some multi-dimensional variables here. This is where it sets up the machine language to read in the fast draw of the maze. And this, I don't know, it's reading in data for something here, probably to do with the difficulty or something, I don't know yet. 900 is the machine language I wrote down, and 910, we're good there. The other thing you want to do is you want to write out all the Go subs. So I went back and I wrote out all the Go subs so that you can kind of track what's doing what. For the most part, I put 840 is initializing data. I didn't do 640. Let's see what 640 is. Maybe because I didn't know. Let's assist it real quick and see what it does. Oh, so basically that drew, let me see, did that draw that box over there? It's like it drew the box on the screen. Maybe it didn't. Okay, I'm not sure what that one's doing yet. I have to take apart the code to figure that one out. So yeah, that's probably going to take a little bit more time to figure out what that's doing right there. Maybe it's level up or something, I don't know. And then we got 510, so we got line 310. This is doing something, and it's going from 510 to 520, 530. And 510, basically, this is saying you found the gold key, so it's probably looking for those characters on the screen. That might be what that editor data was doing too. And then we've got, after all that, line 530. Let's go to 530, which is the editor on. And this one is increasing the gold. That's what G is, the gold. Like I said, based on if you're above 49, it's going to increase the gold. Every time you hit G equals G plus 50, it's already increasing the gold, so I'm not sure exactly what that's doing. Something to do with the gold right there. And let me see, 530, we've got that. 590. So 590 here, this is resetting the monster positions. This dot means 0, by the way. This is the position of the player, so we could change that if we wanted to move in with that. Not sure what this D is yet for. And this right down here, we went over 610. I think we're good on everything now. So I know I went over that pretty quick. I'll post this on GitHub too. And maybe we could just upload the D64 file so you guys can kind of play with it yourself. And let's go ahead and get that sprite initialized. So I'm going to pause here again. Whoops, I started my clock. Okay, so you'll notice now I went in and I changed the light to that sprite data character. I'm going to pause here for a second, show you what I did. I changed it to look like this. So could basically change it to look more like a light surrounding itself, but for now I figured that was the fastest thing I could get to without having to create a whole sprite. And let me show you where I did that. Which I need to turn this off again. I essentially changed it right here. I added 922 new sprite data, and I just read in the routine 12288 to 62, which is how large the sprite's going to be, since it's 8 times 3. Or, is that right? 8 times, well, anyways, it's 62 characters for the sprite. And then we just read it in memory there. And I also moved the return, which ended over here earlier, so we could add in our new data. And then that allowed us to change the background. So next, we'll see if we can go ahead and, I'm running out a whole lot of time here tonight. So to make this easier, since I talked about the redefined characters, let's go ahead and do that next. So as I mentioned, we're going to basically change to some of the background characters, like in the maze and that, to something maybe with these characters in here. I'm just going to use this as an example. Okay, I'm going to show you a trick now. What we're going to do now is we're going to redefine the characters. I mean, we're basically going to change some of these characters. I'm not going to change, for example, any of the actual monster characters. What I want to do is change a more obvious character, which would be the wall. But I wanted to show you a trick here real quick. Now what I did is I stopped this, and what I'm going to do is I'm going to restore the screen so you can see that these characters that are redefined right now are going to change into background characters. Going to change into what they originally were before we changed them. You can see there's a number, there's a dollar, there's a percent, there's an and there's this little quote. Now I'm going to sneak up the camera here a second and show you what I'm talking about here. So if you take a look right there, right here where it says 33, 34, 35, 36, 37, and so on. So what we're going to be doing is we're going to be changing this one, 43, which is the plus character, and that's the one for the wall. So how did I know that? Because they kind of gave it away here. And plus, if you if you break out of the game like that, you can see what they are. But at the very beginning, they gave it away right here by showing you the dollar sign. The skull is the number. The wizard is the dollar sign. The bat is the percent sign. The spirit is the end sign. And then the snake is the little quote sign. That's how I knew not to use any of those. And then, of course, what I did is this. Very similar to just what we did. Let me just pause for a second. So it takes a moment to load there. So I'm going to go ahead and break out again. And we're going to restore the screen again with 53,272, 21. And you can see the plus is the maze, and this little asterisk at the side, you may want to make a note of that one too. The asterisk, which is the 42, I'll just throw that in here for my re-engineering part. This is going to be the wall, the outer wall, I guess you could say. Outer wall. And that's the, was it 43? Or what was it, 42. I'll move these over a little bit. Make it a little bit nice and tidy. Okay, and then this 41 character is going to be this little backward thing right here, whatever that is. But we know our wall, whoops. Let me just erase this. Just tabbing over everything there. So 41, whatever character that is. So the one we're looking for is 43, which is the next one down. So this is the wall, and that's the one we're going to change. The wall looks like the plus sign. So put the character in there so we know which one it is. And then here's how we identify. The way he set this up is actually pretty simple. So we go to 1000. Actually, let me go to 900 to make it a little bit easier here. So you can see all the data. Now this first part is the machine language data, so we can skip over that. The next part he's doing, and I'm going to turn off the sprite so it's not in the way. Right here where it says 00, this is the first part of the data. I believe this is the background they're changing. 0 is always supposed to be the background. And then 35 here, we saw here 35 is the skull, so this is the skull character. 36, as we defined, that's the wizard. 37 is the bat. 38 is the spirit. 39 is the snake. And 40 is the gold. I found that one earlier. That's the gold, and I changed that one already. 41 is whatever, it's probably one of the bad guys, or maybe it's one of the other prizes. But 1030 is the line we want, which is, or not 1040, 1040 is the line we want. So we want 43. So just to make sure in our book, if we look at the plus sign there, we'll see that it shows 43 on the plus sign. Right there. That's the one we want, as I showed you earlier. So we're going to change that to reflect our new data. And I'm just going to basically take some of this data that I found on this, from these screens, basically. I don't know which is which, but we're just going to just take the last one, for example, and see what it does when we change it. So whatever it is going to change the outer part of that menu. Now, you always want to leave the first character, because that's the character it's going to change. And then everything after that is what you're going to copy into the new data here. They had an extra 0 in for the data statements. You don't have to do that, but I think they just did that to make it tidy. There we go. So I added this 520 into our new line here. And I'm going to save just in case. It's always a good idea to save too, just in case your program decides to crash on you. Like anything. Pause there. Takes a little bit of time to run it, then we're just going to run it. Pause again. We can see our other characters are remaining unchanged. We didn't change any of those. And look, we changed the background to this weird character. Not exactly the one I wanted, but we did change it. So we could go in here, we could use any data we want, and we could change it. Now we could also set it to multicolor. Let's do that next. Hi everyone, I decided since this video was getting too long, I'm going to break this one into two parts, part 1 and part 2 for the Catacombs game. There's a lot more work. It's taken me longer than I thought to try to go through and try to reverse engineer some of this stuff. The multicolor is, for some reason, it's not working properly. I think it's the way they move memory around or something here. I'm going to look into that a little bit later, and then we'll play with the title screen. But for now, I hope you enjoyed this video. Please please like, favorite, and subscribe. Sorry, it's like 5 o'clock in the morning, and I got to get up here in a few hours, so I got to be heading out. But I always really appreciate all of your support and everything, and look forward to hearing your feedback. Thanks for watching, everybody.